I'm Anil Kumar. Welcome to my series on solving trigonometric equations. In this video, we'll discuss a very special equation which is of the type a cos x plus b sin x equals to c. We have three examples: square root 3 cos x minus sin x equals to square root 2, square root 2 secant x plus tan x equals to 1, square root 3 minus 1 cos x plus square root 3 minus 1 sin x equals to 2. So these are three different examples which we are going to take up in this particular case. And all these equations, as you will see, can be actually written in terms of a cos x plus b sin x equals to c. Let me change this equation to square root 3 plus 1 sin x. Right, okay. Now, the idea here is to write this equation in terms of either sine or cosine, correct? So, we have always to start with something like this, which is a cos x plus b sin x equals to c. So the idea here is to write this as either in terms of cosine or in terms of sine, then it will be easier to solve, right? So what we do is that we make a substitution for a, and we substitute a as, let me write down here, as r times, let's say, cos alpha. In this case, we will be writing this equation in terms of cosine. And we can write b as r times sine alpha. Right? So in that case, this equation will become r cos alpha cos x plus r sine alpha sine x equals to c. Now if you take r common, you are left with cos alpha cos x plus sine alpha sine x equals to c. Now this is a familiar compound angle formula, so we could write this as r of cos. We can write this as x minus alpha. So the whole thing is cos x minus alpha, and it is equal to c, correct? Now we get equation in cosine, and we can always solve it very easily, right? We can always write this as cos of x minus alpha equals to c over r. Right? So basically cosine is a value between positive and negative 1, and therefore at this stage you will realize that if this equation has a solution, then c over r should be actually less than equal to 1. Let's say absolute value of c over r is between plus and minus 1, right? So r we are always taking as positive, correct? So once we get to this stage, you can very easily provide a solution. Now we could have also written the same equation in the form of sine x minus alpha, right? We could have also written this in terms of sine x minus alpha, provided the substitution would have been r sine alpha in this case. Is that okay for a? So if you would have switched the substitution, I would have got the equation in terms of, well, if it is plus, it will be x plus alpha, right? So that was alternate method. But any method can be adopted. You could either write the equation in terms of cosine or in terms of sine. Now let's further look into the substitution which we made, so that in the examples we'll not explain the whole process. So from here you can see very clearly that what is a square plus b square equals to. If I add their squares, we get r square cos square alpha plus r square sine square alpha. So that means we get a square plus b square as equal to r square, and within bracket we had cos square alpha plus sin square alpha. Now this portion is 1, so we get a square plus b square equals to r square, and that gives you what the value of r is, right? So we get r equals to square root of a square plus b square. Does make sense to you? So here is one very important result. And now another thing which is left to be found is, after all, what is alpha? So r is square root of a square plus b square. To find alpha, we can always write this as what is b over a equals to. If I take the ratio of these two, b over a will be r sine alpha over r cos alpha, correct? Which is tan alpha. So we get that tan alpha is equal to b over a, or you can say alpha is tan inverse of b over a. Does make sense to you? So we do get the value of alpha also. So that's relatively simple. So basically, if you compare this particular form of your solution with these two, let's use another ink. We know what the value of r is, right? And we also know what the value of alpha is. So we know what is alpha, what is r in terms of a and b. And so we can easily solve this equation. Does make sense to you? Correct? You can write c over r in terms of cosine and get your answer. So now we are going to adopt this strategy and solve these three questions one by one. So let's see how to do it. So I hope the concept is clear, right? Now let us see how to solve this kind of equation. Square root of 3 cos x minus sin x equals to square root of 2. So as explained, the idea here is to write the whole thing as r of cos alpha times cos x minus r of sin alpha sin x equals to square root of 2, correct? So that is the idea. So that we could write the left hand side as r of cos of x plus alpha, right? That's the compound angle formula, equals to square root of 2. That is the whole idea, correct? Now keeping this strategy in mind, what substitution are we going to do? Well, clearly we have r of cos alpha equals to square root of 3, right? And r of sin alpha equals to 1, right? We'll not take negative. We are using negative here, and so we get the formula cos x plus alpha. Perfect. Now, if you add their squares, we know r will be equal to, if you add their squares, we get this square plus that square, as we explained, will be equal to square root of a square, which is square root of 3 square, plus 1 square, which is square root of 4. So the value of r is 2. Ratio of these two will give you tan alpha. So tan alpha is 1 over square root 3. Getting back to our special triangles, we know that the value of this is pi by 3. So if this is 1, this is 2, this is square root of 3. Since we want 1 over square root 3, we are looking at this angle, which is pi by 6, right? Or 30 degrees. So from here, we get the value of alpha as equal to pi by 6. Is that clear to you? Right? So now that is a substitution which helps us to reduce the left side in terms of just cos. Correct? So moving forward, what we get here is that we could write square root of 3 cos x minus sin x square root 2 as equal to r value is 2, cos of x plus alpha, which is pi by 6. And this is equal to square root of 2. Is that clear to you? Now we can isolate cos. So we get cos of x plus pi by 6 equals to square root 2 over 2. Now square root 2 over 2 for the cosine function is, as you know, possible when we have the value in quadrant 1 and 4. Correct? So these are the two values which will give you cos as positive, and the angle here is pi by 4. This is minus pi by 4, correct? So from here we can say, well, you could also write like this, that this is possible when x plus pi by 6 is equal to plus minus pi by 4. Is that clear to you, right? So that becomes the value for both the angles, and therefore the value of x can be written as plus minus pi by 4 minus pi by 6. So that is when we are restricted to the domain of 0 to 2 pi, correct? But we could also write a general solution in this case. So work on it here. So we have x equals to pi by 4 minus pi by 6, and also we have minus pi by 4 minus pi by 6, right? So both are possible. So let's simplify them, taking 12 as our common denominator. So this goes 3 minus 2, and here we get 12 as a common denominator. We get minus 3 minus 2. So the value of x will be 1 over, pi, of course. So basically pi over 12, and in this case minus 5 pi over 12, correct? So we get two solutions. That is when the domain is restricted to 2 pi. In general, so we can write general solution, which will be x equals to 2n pi plus pi by 12 and 2n pi minus 5 pi by 12. Do you see that? So that becomes our general solution, and that is what we should be writing as our solution for the given example. Is that clear to you? So the idea is to understand this strategy, begin with thinking what final result you want. We want to write this in terms of cos x plus alpha. So we made a substitution, r cos alpha and r sin alpha, as shown here, and then using this we could find the value of r and alpha. And later, important part is that we have more than one solution. We have to incorporate both solutions in our final result and write a general solution if the domain is not given to you. Is that clear to you? So that is how we are going to do it. Now let's take up another example. The question here is to solve square root of secant x plus tan x equals to 1. We need to write this in terms of sine and cosine and simplify. That will be our first step. Now secant x is 1 over cos x, so I could write this equation as we can write this as 1 over, rather square root 2 is there in the numerator, over cos x, and tan is sin x over cos x equals to 1. Now cos x is a common denominator. We could multiply each term with cos x. So we get square root of 2 plus sin x equals to cos x. Now that can be simplified. We can now write this as cos x minus sin x, taking it there, equals to square root of 2, correct? Now we get a familiar form of the equation like a cos x plus b sin x. Now to solve this equation, we could always write this in the form of r cos alpha times cos x minus r sin alpha times sin x equals to square root of 2. Now, the idea of writing r cos alpha, r sin alpha is basically to write this in one particular trigonometric ratio, which is cosine. Now here, the left hand side can be written as r of cos of x plus alpha, right? And equal to square root of 2. Now how did we get this equation? We made a substitution, which is we substituted r cos alpha for 1 and r sin alpha for 1. Do you see that? And then we got this form and we wrote it in the fashion given. So the substitution which we made here was, let me write here as r sin alpha equals to 1 and r cos alpha as equal to 1, which are the coefficients of sine and cosine. We maintained this negative sign so that we could write our final solution in terms of cos x plus alpha. Now, the ratio of these two will give us tan alpha, which is 1, and that means alpha is equal to pi by 4. Right? So we get this alpha is pi by 4. Right? So that's one thing. Second thing about this substitution is that the value of r, if we add in square of these terms, we get r square sine square alpha plus r square cos square alpha equals to, add them, 1 plus 1, which is 2, right? So we get r square equals to 2 or r equals to square root of 2. So from here, we can write down that we have square root of 2 for r, cos of x and alpha is pi by 4. Is that clear to you? Equals to square root of 2. Or we can now solve this further and say cos of x plus pi by 4 is equal to 1. So cos of x plus pi by 4 is equal to 1. Now when is cosine 1? Cos is 1. We can always sketch and see, right? So in one cycle, cos is 1 at 0 or 2 and pi, correct? So that is when the cos value is 1. So that means that x plus pi by 4 is equal to 0 or 2 pi, right? So we can say it is equal to 0. So in that case, cos is 1, and we get the value of x as equal to, so from here we get the value of x as equal to minus pi by 4, correct? So that is the value of cos, which is minus pi by 4. We can actually now write a general solution. So general solution will be x equals to 2n pi. Since it is a way which is periodic, pi by 4. Is it okay? So that becomes our answer. So I hope the steps are straightforward. So the idea here is to write the equation in terms of sine and cosine. So when you get it in this form, we actually convert it to a wave equation. This is also called a wave equation. A simple harmonic motion is described by this wave by making these substitutions. And then we have equation in one trigonometric ratio which can be easily solved. And a general solution should be provided since no conditions are given on it. So I hope these steps are absolutely clear. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best. Square root of 3 minus 1 times cos x plus square root of 3, let me make this plus 1, times sin x equals to 2. Now to solve this equation, we'll like to write this in terms of sine. So I want to make a substitution so that I could write this as r of sine alpha cos x plus r of cos alpha sin x equals to 2. So once I do that substitution, I can always write this as r of sine x plus alpha equals to 2. So that's the whole idea, correct? Now that really means that we are going to write r sine alpha as equal to square root of 3 minus 1 and r cos alpha as equal to square root of 3 plus 1, right? There was a typing error, I made it plus 1. Now clearly from here we get the value of r. If we add squares of these, right? So if we add squares of these, then we get r squared. Their sum is 1, so r square equals to square root of 3 minus 1 whole square plus square root of 3 plus 1 whole square, correct? So we can simplify this. So this is 3 plus minus, that becomes minus 2 times square root 3 plus 1, and squaring this we get 3 plus 2 square root 3 plus 1, and that is, these two terms cancel. We get 3 plus 3 as 6 and 1, 7 and 1, 8. So r square is 8, and that gives you r as square root of 8, which is 4 times 2, so 2 square root 2. So we get the value of r as 2 square root 2. Now we need to find what the angle alpha is going to be in this particular case. To find the angle alpha, we'll take the ratio. So we get tan alpha as equal to square root of 3 minus 1 over square root of 3 plus 1. Now what we could do is divide by square root of 3 to rewrite this as equal to 1 minus 1 over square root of 3 over 1 plus 1 over square root of 3. Now that reminds you, 1 is tan of pi by 4, correct, minus 1 over square root 3. You can use your special triangles. So in a special triangle, the sides are 1 to square root 3. We are talking about 1 over square root 3. So we'll look into this angle, which is pi by 6. Correct? So we get tan of pi by 6 over 1 plus, you could write this as product of tan pi by 4 and tan pi by 6, just to complete the formula, right? Right. So this could be written as tan of a minus b, which is pi by 4 minus pi by 6. Okay? So pi by 4 minus pi by 6 is, let's complete this, taking 12 as your common denominator, 3 pi minus 2 pi, so we get pi over 12. So we know angle alpha is basically pi by 12. Is that clear to you? So there's a lot of work which we have to do in this substitution. So that coefficient makes it slightly more complicated. Perfect. But anyway, we got the value of r, we got the value of alpha. So we could write this as r is 2 square root 2. So we get 2 square root 2 sine of x plus alpha, which is pi by 12, equals to 2. Now dividing, we get sine of x plus pi by 12 as equal to 2 over 2 square root 2, which is 1 over square root 2. Now as far as sine is concerned, it is positive in quadrant 1 and also in quadrant 2, right? So those are the two angles which we are looking into. So we can now say that x plus pi by 12 is equal to this angle pi by 4 and also this angle 3 pi by 4. Right? So those are the two solutions for us. So accordingly, we get x as equal to pi by 4 minus pi by 12, or we also get x equals to pi by 4, 3 pi by 4 minus pi by 12, correct? So the first one gives us, taking 12 as the common denominator, 3 minus 1 is 2 pi by 12, or so 3 minus 1 is 2, 2 pi by 12, or pi by 6, correct? In this case, we get x equals to 9 minus 1 is 8, so we get 8 pi by 12. 3 times 3 is 9, right? Taking 12 as common denominator, 9 minus 1 is 8. And you can now divide by 4, so 4 times 2, so 2 pi by 3. So those are the two solutions. So we can now write a general solution here. So general solution will be x equals to, since it's a periodic function, 2n pi plus pi by 6. The other one is 2n pi plus 2 pi by 3. You see, that is how we are going to solve this particular question. So I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.